Okay, problem 8.33. Given the function f, 1 plus x divided by 3 plus x squared, plot the functions g is the supremum for all y that are greater than x of f of y, and x is the infimum for all y that are greater than x of f. Okay, this is these two are complicated functions. So first, let's deal with f. Okay, so f is 1 plus x divided by 3 plus x squared. It's easy to see that the limit when x goes to plus and minus infinity of f is going to be 0. Okay, good. Now, and this has a 0 at minus 1, right? F at minus 1 is 0. And then let's compute the derivatives to find the extrema of this value, right? So you have the derivative of this times this minus 1 plus x times 2x, so 2x minus 2x squared divided by 3 plus x squared, and this is equal to 3 minus 2x minus x squared divided by 3 plus x squared over 2. If you find the roots for this, you're going to find these are, let's see, this is x squared plus 2x minus 3 equals 0, x is minus 2 plus minus 4 plus 12, 16 divided by 2, so 1 plus minus 2. So it's either 3 and minus 1. So this is 3 and minus 1, yeah. So this is 3 minus x, right? And then, sorry, 3. Yeah, yes, sorry, this is minus 1. So this is minus 3, yeah, sorry. This is 3 plus x times 1 minus x, if I'm correct. Yep. And then divided by 3 plus x squared over squared, right? Now this is going to be 0 obviously at 1 and minus 3, right? Now between, this is a negative parabola, so this is positive here and negative here. So this is growing up until you get to minus 3. Let's see, the value of f at minus 3 is 12 here, minus 2 over 12, minus 1/6, and sorry, decreasing until you get to here, growing, passing through 0 here, and then you go to 1, which is 1/2, and then after that you're decreasing, right? So that let's say this is f. You have a 0 at minus 1, right? Then at minus 3 you have your minimum here, and we know this is going to be negative after this. There's no more roots, and then you have this, like, and then at 0 you have 1/3, so it's okay, something like this. And then at 1 you have your maximum, and then you go back to 0, something like that. And I am assuming there's a change of concavity here and here because the asymptotes are 0, right? So that's f. Okay, now let's see what's g. Okay, now g is a function that at each point x, so let's suppose this one, okay, suppose that you have this x. Now g is the supremum of the values of f from here to here, right? So this is going to be this one, right? And so it's, how to say this, from this point, right? Suppose that g, you choose this one, right? So g is the supremum of all of the set of all these values, right? So it's this one. So whenever f is decreasing, right, g is the value of f of that point. So let's say this is f if x is greater or equal than 1. Okay. Now what happens at if x is smaller than 1? Okay, if g is here, right? Now the supremum of all these values is this one, 1/2, which is the maximum of f, right? If you're in any point here, right, the supremum of all this curve is always 1/2. So this is going to be 1/2 whenever x is smaller than 1. So the point of this is constant until you get here, and then this plot. Okay, this is g of x. Do you see? Now what happens with h? H is going to be the same thing. The infimum of f for y greater than x. And as you can see, right, if you're here, the infimum of this set is going to be 0. The infimum of, if you start here, is going to be 0. The infimum here is going to be 0. So if you're between -1 and if you're greater than -1, right, you're going to be, the infimum of this is going to be 0, right? Now, the infimum of this set between this and this is going to be exactly the point between the minimum, right? This is the minimum at -3, -1, 6. This is going to be the value of f between this and this, right? So this is f if x is between -3 and -1, right? And then if f is smaller than this, then the infimum of this set is always going to be the minimum, the absolute value of this, okay? It doesn't matter where you are here. So this is -1, 6. If x is smaller than 1, -3. So the function here is going to be like this. This is -3. You have something like this, right? This is the function. Then you increase up to here, and then you have a 0. That's h. Okay?